So dear friends, we'll start with 3 hinge arches we'll be trying to explain this with a numerical example. A 3 hinge parabolic arch hinged at the crown has a span of 24 meter, a central rise of 4 meters. So here we'll be showing a 3 hinge arches with a span of 24 meters and a central rise of 4 meters as it is given there in the problem. It carries a concentrated load of 50 kilonewton at 18 meter from the left support and a UDL of 30 kilonewton per meter over the left half portion. So here it is given that 50 kilonewton, a concentrated load at 18 meters from the left support and a UDL of 30 kilonewton per meter over the left half portion. So what we are supposed to find out? Determine the bending moment. So we have to just try to understand the given question. Bending moment. Determine the bending moment. Thrust and radial shear, that is normal thrust and radial shear, all at a distance of or at a section 6 meter from the left support, at a section 6 meter from the left support, at a distance 6 meter from the left support. I'll say that it is at a distance of x is equal to 6 meters. So we'll just give the names A, B and C and we'll try to find out the reactions for this. So will be, since this is a hinges, these are the hinges, 3 hinges, so we'll be just finding out the reactions there. So while finding out, I will be applying the equations of static equilibrium. We'll be just writing as it is whatever given, 30 kilonewton per meter, 50 kilonewton, and it is at a distance of 18 meters and 24 meter is the span given. Okay, so here I'll write the names as A and B, C. So here, since it is a hinge support, it will have one vertical reaction, one horizontal reaction here and one vertical reaction here. I will write the name as VA, VB, then HA and HP. So here we'll apply the equations of static equilibrium. So like for applying equations of static equilibrium, we'll be writing this as summation of Fy is equal to 0, so which gives Va plus Vb, and that is nothing but 30 into 12 plus 50 is the downward forces. Va and Vb are the upward forces, so we can find out 410 kilonewton as the total reactions. So by taking moment at A, we can find out 30 into 12 into 12 by 2 plus 50 into 2. Likewise, we can calculate Vb and Va. Okay. After calculating Va and Vb, we can find out what is the horizontal reaction component, and that is 307. We can take either from the left half portion or the right half portion. So we can calculate the HA, that is nothing but the horizontal reactions. And after that, since it is given as a parabolic arch, so a typical example we have taken, since it is a parabolic equation, a parabolic arch is there, so we can write for a parabolic arch y is nothing but 4hx divided by L square into L minus 6. So we are applying, we are finding out bending moment, normal thrust and radial shear at a distance 6 meter from the left support, or at a distance x is equal to 6 meter from the left support. So likewise we can calculate for y is equal to x is equal y at x is equal to 6, so it is 3 meters. Means what we are calculated, the central rise given in the problem is 4 meters. Okay, but here we are supposed to find out at a distance of 6 meter from the left support. So while you calculate that, we are getting 3 meters. So likewise we can calculate bending moment at x is equal to 6 meter from the left support is nothing but 282.5. that is 282.5 is the vertical reaction components we can calculate. Okay, so here into this distance is nothing but 6 meters, so that's what we have written, 6 meter minus of this 30 into 6 into 6 by 2, so that's what we have written. Okay, minus the horizontal reaction component we have calculated, and that is 307.5 into 3. So we can calculate bending moment at 230 at 6 at x is equal to 6 meters, that is nothing but 232.5 kilonewton meters. Likewise we can calculate the normal thrust. In the normal thrust we have 2 points, that is one is the shear forces. So the shear force is nothing but we have to calculate the shear force only for the particular left hand portion, that is nothing but I can say the point as D. So at this point we are supposed to find out, so it is 282.5 minus 30 into 6, since we are calculating the reaction shear force at 6 meters from the left hand support. So we can calculate 282.5 minus 30 into 6 is 102.5, and horizontal force already it is calculated, and theta we know that it is nothing but a slope. So slope is calculated by differentiating this y equation, that is nothing but a parabolic equation, with respect to x. So we can calculate and we'll substitute the values. L is nothing but the span of the arch, that is 24 meters given in the problem. Then central rise is 4 meters. H is the distance at which we are finding out, and the slope is nothing but 6. So after substituting the values we are getting the theta as 18.435 degrees. Now we have equations given. We are having the equations, that is normal thrust is 2 sin theta plus h cos theta, and radial shear is v cos theta minus h sin theta. After substituting the values we'll be getting that normal thrust as 324.1 kilonewtons. Okay, so likewise we are calculating radial shear, it is denoted as q, and we are getting 0, hence the solutions.